Welcome back! Today, we're diving into how to determine the volume of cylinders, cones, and spheres. Let's get started. Now, before we jump into the volume formulas, there's one key number we'll be using: pi. Pi represents the ratio of a circle's circumference to its diameter. In simple terms, no matter the size of the circle, if you divide its circumference by its diameter, you'll always get about 3 14/100ths. Pi is an irrational number, which means it has an infinite number of decimal places. But for most calculations, we round it to 3 14/100ths. We'll be using pi in all three volume formulas today, so keep that value in mind. Now, two of the shapes we're talking about today, the cylinder and the cone, require us to first calculate the area of a circular base. And we do that with the formula area equals pi times radius squared. This is an important formula because both the cylinder and the cone involve multiplying the area of the base by the height of the shape. So let's keep this in mind as we go forward. Let's start with the cylinder. A cylinder is a 3D shape with two identical flat, round bases connected by a curved surface. The sides are straight and the bases are parallel. To find the volume, we need two things: the radius of the circular base and the height of the cylinder. The formula for the volume of a cylinder is volume equals capital B times h, where capital B represents the area of the base and h represents the height of the cylinder. Since the base of a cylinder is a circle, we can rewrite the volume formula using the area of a circle formula in place of capital B, pi times the radius squared times the height. For example, let's find the volume of a cylinder with a radius of 3/4 of a meter and a height of 4 meters. By substituting the given values for the variables into the formula, we can calculate that the volume of the cylinder is approximately 7 7/100ths cubic meters. Next, let's look at the cone. A cone is a 3D shape with a circular base and a single point called the apex, where all the lines from the base meet. The surface is curved and comes to a point. The formula for the volume of a cone is similar to that of a cylinder. But since a cone tapers to a point, its volume is 1/3 that of a cylinder with the same base and height. The formula is volume equals 1/3 times capital B times the height, where capital B represents the area of the base and h represents the height of the cone. Similar to a cylinder, we know the base of a cone is a circle, so capital B is equal to the area of a circle, pi times the radius squared. Let's calculate the volume of a cone with a diameter of 6 feet and a height of 5 2/10 feet. Now, before we start, let's quickly review the relationship between radius and diameter. The radius is half the length of the diameter. So if the diameter is 6 feet, the radius is half of that, 3 feet. Now that we know the radius, we can use the formula for the volume of a cone. By substituting the given values for the variables into the formula, we can calculate that the volume of the cone is approximately 48 98/100ths cubic feet. Finally, the sphere. A sphere is a 3D shape where every point on the surface is the same distance from the center, creating a perfectly round shape. To find its volume, we use the formula volume equals 4/3 times pi times radius cubed. Let's calculate the volume of a sphere with a radius of 7 inches. By substituting the given values for the variables into the formula, we can calculate that the volume of the sphere is approximately 1,436 3/100ths cubic inches. To recap, for a cylinder, the formula is capital B times h, or pi times the radius squared, times the height. For a cone, it's 1/3 times capital B times h, or 1/3 times pi times the radius squared, times the height. And for a sphere, it's 4/3 times pi times the radius cubed. Thanks for watching, and as always, stay curious and stay fresh.